happy to talk about any of the technical details and maybe provide some hints towards where we're headed in the future. All right, so with that.
Hey, Michael, I joined. Is it okay if I say hi to everybody?
Excellent. Yeah, please do. Sorry, I missed that.
Hello. Hi, everybody. I'm Steve Greenberg. I lead the developer relations team over here on Earth Engine, and it's super excited. I was really excited to get this request from Nicholas, and Michael and I are here to talk to you about Earth Engine and BigQuery, and we'll keep it fast and loose. Feel free to ask questions.
Awesome. Thanks, Steve. And you're based in Seattle, Steve, so it's super early in the morning there.
It's not that early. This is my second meeting.
Very different from Europe. Constantly staying up late. A few friends here as well. We got the dream team. Excellent. Yeah, so I'm going to assume, as I'm presenting here, I'm going to assume that you all have, given that it's the Earth Engine group, a working knowledge of Earth Engine and how Earth Engine works and the general pieces. If you have questions about the Earth Engine pieces of this, as we're talking about the relationship of BigQuery and Earth Engine, feel free to interrupt. Feel free to ask questions. There are no bad questions here. For folks who haven't heard of BigQuery, so if you do geospatial analysis, you may not have used BigQuery before. BigQuery is another Google tool that is in some ways very similar to Earth Engine in philosophy. It's really about abstracting away the IT and the infrastructure, providing petabyte scale analysis so that you can do very easy workflows like building machine learning models, ripping through petabytes of data, not have to worry about how it's hosted, how it's stored and encrypted, which columns are indexed, et cetera, et cetera. So it's really a table analysis tool. You interact with it via SQL. So if you use other database applications, you already basically know how to drive BigQuery. So BigQuery is another tool in the Google Cloud sort of set of APIs and services. The thing that I think of myself first and foremost as an Earth Engine user. The thing that BigQuery has that I think many other Google applications and products aspire to is a really huge surface area. So there are lots and lots of tools that speak BigQuery and can write data into BigQuery. You can put logs data into BigQuery. You can plumb data from Google Drive. You can upload from analytics. You can upload from Earth Engine, which we'll talk about in a bit. Lots and lots of different services push data into BigQuery. So it has a really large input surface, if that makes sense. That's complemented by a really large output surface. So BigQuery data can be fed into other systems. So if you do analysis and processing, you clean up a bunch of for example, geospatial tabular data, you can very easily plumb that into any of the products listed here: Google Sheets, Cloud ML, Tableau, Looker, Pandas for further data science. I want to say a very fluent service. BigQuery is able to read from and write to many different places. And given that Earth Engine can push data into BigQuery, this is what we see as a really big opportunity for use, for being able to integrate with other systems, kind of from Earth Engine through BigQuery into other things. That's not to minimize the amount of stuff that you can actually perform in BigQuery. BigQuery has built within it a really rich set of geospatial tools and, of course, tabular data analysis tools. But this, for me, is a really exciting point that getting data to BigQuery doesn't mean that they're in BigQuery. It means that they're in BigQuery plus a bunch of other services. So if you have a good mental model of Earth Engine, Earth Engine is a big calculator for pixels, a big calculator for raster data, obviously very, very serious geospatial processing with a really large catalog. And this idea of very scalable compute. So you can do a small amount of processing, like a single tile, or you can process the entire world and move petabytes of data around and do very deep machine learning, build deep machine learning models, for example. BigQuery is basically the same thing. There's one word different between these two columns here, and that's really BigQuery operates best on tables. So Earth Engine really operates well on pixel data, pixel grids, images, rasters. Those are all synonyms. They're all the same word for just sets of pixels. BigQuery works really well for tables. So if you have in Earth Engine land a feature collection, a set of rows with geometries, properties, a list of different vector entries, that's really where BigQuery excels. And Earth Engine does have table support. There are feature collections, but BigQuery scales way, way bigger. You can do much more compute-heavy computations. BigQuery has been designed for making many of these operations really fast and efficient. Steve has a nice example. Maybe he can talk about it later, where Earth Engine took a day to perform a really large spatial join, and BigQuery did it in seconds.
Yeah, especially if you're just operating on vectors, on features, and you're not operating in raster space at all, as we like to say, BigQuery can do a really good job on that, and it is just tuned for that scenario in particular very well.
All right, so that's BigQuery in a very quick overview. Please raise your hand. Feel free to interrupt if you have questions, if there's anything else that you'd like to learn before we start talking about the wiring and the plumbing. Going once.
By the way, just to give a little bit more detail on that example, because I realized I just sort of, I didn't provide it yet. The example there was actually work that we were doing to sort of, with our partner, the Environmental Defense Fund, and we were looking at oil wells, and we had two sets of data, each with millions of potential wells, and we wanted to basically deduplicate them effectively, do a spatial join to figure out which points in one data set were actually the same as the other. So across 6 million points, we were basically finding the pairwise matches between each one, and that's a particular kind of operation that just distributes really well in BigQuery.
Yeah, if you find that you are running into out of memory errors, particularly for things like joins or just kind of pure table operations. So you're just working with feature collections, you're reducing feature collections, you're doing processing between feature collections, merging feature collections. Those are really optimized in BigQuery. And I'd encourage you to sort of explore BigQuery if you're running into out of memory errors, timeout errors, any of the sort of common compute errors that you can run into in Earth Engine. All right, talk about plumbing. So this is a little bit of a historical context. This is to give you a sense of the idea of typically what is involved in moving data between systems within Google Cloud. So this is, we talk about this as the before. This is about a year ago at this point. Before we launched a direct connector from Earth Engine to BigQuery, you kind of had to do a couple steps, and they weren't particularly tough steps, but they were extra steps that had to be performed, were a little bit challenging to automate, and required a little bit of context and sensitivity to the requirements of each of the steps. So if you had data in Earth Engine and you wanted to get it in BigQuery, what you previously had to do was, your best option was to export to some intermediate storage system like cloud storage or Google Drive, and you were responsible for making sure that the encoding was correct, that the amount of data that you exported was something that makes sense for BigQuery. I'll talk about some of the limitations, but you can't have more than, for example, 8 megabytes per row. So you were responsible for checking that as part of your Earth Engine export, and then you have to somehow trigger that ingestion, that data movement into BigQuery. So that's the before. Not a super frustrating thing, but there were some sharp edges. And so I can talk at length about some of the specific challenges. It's really just there are two different computation systems, and they have different expectations for what the data look and feel like. So what projections are supported in Earth Engine versus BigQuery, for example, or the ways that they interpret the GeoJSON standard when talking about geodesicness, whether a geometry is geodesic or planar, whether it's projected or tessellated. And so these are just differences in systems. We built this connector that's sort of cutting to the chase. We built this connector really to make it easy to bring data from Earth Engine into BigQuery. And what this is it's just a batch export tool, one of the batch export functions, which lets you write an Earth Engine feature collection directly into a BigQuery table. So you don't have to manage any of that intermediate storage, any of that intermediate encoding. All of that is just built in, and your data go from Earth Engine into BigQuery. You still do have some of the constraints, but now we have the function will warn you, give you error messages, etc. Where previously you had to kind of discover what those limitations were yourself. Yeah, I've carved out a little space for a demo here. Steve, if you want to warm up your BigQuery Studio, you can feel free to take over the presentation.
Sure.
I will point folks, while you get that set up, I'll point folks at this URL. It's not exactly what Steve is showing here today. This is kind of a first version. But feel free to take a look. This is a blog post that we published that just kind of talks through some of the pieces and how to drive something similar to what Steve is working with here today. Yeah, with that, take it away, Steve.
Okay, thanks, Michael. For those who have maybe just do folks here have any experience with Google Cloud at all, or just with Earth Engine? Maybe folks can sort of give a plus sign if you have experience with Google Cloud, and maybe give a in the meeting give a maybe what do we have? We've got maybe a thumbs. You can feel free to give me a thumbs down sign if you don't. Okay, so actually a lot of people here have some experience with Google Cloud. Okay, that's great, but not everybody. This is really great information. Thanks. Okay, well, now that I know that most of you have some experience with Google Cloud, I'll sort of point out that this is just the Cloud Console. It's where you start for when you're doing anything in Google Cloud. So console.cloud.google.com. Because I'm actually on an internal email address, it redirects to Pantheon. Pantheon is just the code name internally for Google Cloud's console. I apologize that that's confusing. In the left navigation here, you have access to all of the products that are in Google Cloud, including Google Cloud Storage and Google Compute Engine and Kubernetes Engine for running code, and Vertex AI for running your models, and all the configuration for identity and access management, for sort of controlling who has access to your data, and billing, paying for Earth Engine or Google Cloud. That's all here. What we're going to be looking at here is BigQuery. Which, by the way, if it's not in the left navigation inside of Google Cloud's console, you can pin it, search for it, and pin it here. As Michael mentioned, BigQuery has like a pretty broad surface area here, but we're going to be specifically looking at BigQuery Studio. And that's sort of the main code editor for BigQuery. And so you click BigQuery Studio and you come in here. Now, BigQuery Studio's main sort of interface is actually SQL. There's a SQL interface. And so, for instance, if you wanted to look at Wikimedia page views, you could do this, and you could you could query it from here by doing let's see, if we copy this, you could push the plus button and create a new SQL query and select star from limit 10. Yes, question, Nicholas.
Now, would you mind sharing the links to the Google Cloud in the chat?
Yes, of course, yes. The links to Google Cloud's console.
Yep.
Sure, it is right here. Oh, perfect. Yeah, console.cloud.google.com is always where I start. Earth Engine is not yet queryable via SQL inside of BigQuery. In order to use Earth Engine, you have to use one of two languages, either the JavaScript language inside of the Google Earth Engine's code editor, or Python. And of course, the Python experience in Earth Engine has received a lot of improvements in the last 18 months. A lot of the sort of work there and the progress is actually thanks to Dr. Qisheng, who's on the call here. And we partner closely with Qisheng on GEEmap. We're really excited that GEEmap brings a lot of the experiences that you get from the code editor into a Python environment. And that's particularly cool for BigQuery users because there's already a BigQuery Python experience. Let me get a little bit of a show of hands here in terms of thumbs up if you've used GEEmap, and maybe a thumbs down if you haven't, just so we can sort of understand. So let's see. Okay, so this is great. You folks know this already. I'm just gonna show you how to stitch it all together. Was there a question there? Happy to take questions as we go. Okay. So what I'm in here is I'm in the Python experience inside of BigQuery Studio. And the way I got to that, if you were in the home experience here, just like you can create a new SQL query, you can also create a new Python notebook. The Python notebook experience is based on Colab. Do folks know about Colab? Colab, I'll just quickly bring it up here. Colab is a notebook experience. Folks may be familiar with Jupyter Lab or Jupyter Hub. Those are other notebook experiences. Colab is one that was built by the Google research team with researchers in mind, which is pretty cool. And they've also, though, it's a pretty neat experience, and it actually is used behind the scenes to drive Python notebooks in BigQuery. And so you can go in here, and in this demo, what we're going to do is we're showing you how to basically bring data from Earth Engine that you can only get in Earth Engine, query it, derive an insight, and then combine that, join it together with BigQuery data. And the specific scenario that actually Michael put this together with also help from our customer engineer, Genna, who some of you may know, is actually around sort of identifying the roads that were flooded in a particular flooding event that happened in Belgium in 2021. The scenario is very specific, but it's also it's representative of I would say a broad set of climate risk scenarios that are useful for sort of anybody in understanding kind of the risks that areas may face in the coming decades. And the first line of code here that we run is importing the Earth Engine and GEEmap libraries and initializing Earth Engine and pointing to this project. The project, by the way, that we're using here is an Earth Engine demos project. You can see that we're initializing it there, and we're also selecting it in the upper left-hand corner. Those should match for this to work optimally. Also, I will note, Earth Engine, for a while now, you've been able to use it in the context of a cloud project, regardless of whether Earth Engine is used in a commercial or non-commercial basis. Moving forward, actually, we're going to be pushing for more and more folks to sort of use cloud projects when they use Earth Engine. There's a bunch of reasons for that. There's a bunch of monitoring capabilities and permissions and things that you get for free if you're using Earth Engine in the context of a project. You've initialized Earth Engine for the project. One line of code that I did not have to write here is an authenticate call. Because I'm operating inside of the context of Cloud Console, actually Earth Engine already knows who I am, which is super nice. It just saves a number of clicks, but if you're going here and you're working inside of Colab, you actually do need to basically, you need to do an ee.authenticate call. Okay. Then I specify my area of interest, which in this case is a rectangle in Belgium. And then I'm just going to sort of open up GEEmap and show that that rectangle. One of the things here that's pretty cool about Colab is, although maybe a little bit counterintuitive, is that whatever object you have as the last line of code in your code cell, Colab is going to go ahead and display for you. So that means that if you finish your code cell with a call to map Colab is going to basically display that map for you. I should also mention, it sounds like most folks here have some experience with Colab, but one of the nice things about Colab and other notebook environments is that you can mix together the code with sort of just markdown language to describe what you're doing. So that's why we can have hyperlinks here. And then you also, Colab notebooks are always built for sort of visual exploration of data. They really came of age in sort of the machine learning and data analysis workflows with Python libraries like matplotlib that allow you to basically view charts and view the sort of accuracy of your machine learning model as you're building it. Data scientists love this, but that also makes them a really good fit for folks who want to work with maps. Because Earth Engine exploration is it's inherently a visual experience, and trying to do exploration of maps outside of or exploration of remote sensing data without a map is just really arduous and hard. And so we think it's a really good fit, and that's one of the reasons we're so excited about what Xisheng has built with GEEmap. Okay, so you've got this rectangle here that shows you that's basically the area that we're going to look at in Belgium. The next thing we're going to do is we're going to load in Sentinel-1 data, radar data that can help you understand what areas are flooded and what areas are not, because the Sentinel-1 sensor returns a different, basically values are different depending on whether you're sort of reflecting over land or reflecting over water. That's a very layman's explanation, and I bet most of you in the room here can actually explain that better than I can. But if this code looks familiar, it's sort of by design. We've tried to make the Python interface to Earth Engine as similar to the JavaScript interface as possible. We're loading in the Sentinel-1 data set, and we're filtering it for a particular band and for the ascending pass rather than the descending pass. And then we're basically filtering out before the event, before the flooding event, and then after the flooding event. Smoothing out the data, removing salt and pepper noise, and then the last thing we're doing is we're reducing the rasters to vectors. And so we'll run this code and visualize the flooded areas. As with Earth Engine in JavaScript, by the way, yes, I'm happy to, Nicholas, I'm happy to share the notebook, definitely. As with sort of the JavaScript code editor, it's interesting, you probably saw that these lines of code, it almost ran instantaneously. And that's because just like with JavaScript, we don't actually do the computation until you actually display the result. So the result, the operation that caused our backend to do the compute was actually the display of the map right here. And here you can see the flooded layers, the areas that were flooded within this particular rectangle. We're going to move on at this point. This is where we want to, join to the road segments. Now, the interesting thing is that the road segments are an OpenStreetMap, and OpenStreetMap is a data set that's available inside of BigQuery's public data catalog. So just like Earth Engine has a data catalog of geospatial data, BigQuery has a public data catalog. BigQuery's data catalog here has a bunch of data. Where is it? Public data catalog. Usually it shows up here. BigQuery public data. Thank you. There's a ton of data. I will say BigQuery's public data is not, most of it is not necessarily geospatial. You might see, for instance, Bitcoin's blockchain here, and COVID data. But there is some public data, and for instance, the OpenStreetMap data is one example of some geospatial data inside of BigQuery's public data catalog. In order to do the export, you kick off an export task just like you do in Earth Engine. I've actually already done that, and just to save us the time during this demo, I'm not going to rerun it. So that's why I've commented out the code. But basically, what this would do is it exports the data into an Earth Engine table using the API that Michael described just a few minutes ago. And now we're going to do a join. This is where we write SQL, and we're actually writing SQL inside of a notebook. Just to keep it formatted nicely, you can use this BigQuery this percent is called a magic, and you use that to basically join the data together. And you can see that we're executing the job. And the result here is that we're creating a table. And what we're doing here is we're actually joining together the OpenStreetMap data with the flooded polygons that we just exported a second ago. Yeah, Nicholas. Do you have a question?
Yeah, you are not in presentation mode.
I see. How did that happen? Let me duck out and then let me stop sharing.
Yeah.
And Michael, maybe you can stop sharing as well.
Sure.
And then I will share again. Window, boot, boot. Thanks for mentioning that.
Yeah, you were still sharing, but it was unpinned. I don't know what magic causes that.
Yes, Google Meet continues to sort of stymie me. Michael, do you have a question?
Oh, okay. Sorry, I had a concern like the one Nicholas had. Yeah.
Okay, same one. Okay, great. So we just joined together the data, and then we're going to download the data as a GeoJSON. There's a small amount of data of work here to basically reformat the results as a GeoJSON structure, and then download them. And then with GEMap, we can now take the same data that we showed just a few minutes ago, which was the flooded segments, and now also add to the map, sorry, the flooded areas, and then add to the map the flooded road segments. So in this situation here, what you're seeing in blue are the flooded areas, and in red, you're seeing the road segments that intersect those areas. And so that's just a simple demo. That's the end of the demo that demonstrates how to sort of take the best of Earth Engine and then join it together with BigQuery data. I think, yeah, Michael and I are happy to take questions that you've got.
So just to recap, that's bringing pixels in Earth Engine, transforming them into patches using reduced to vectors, moving those patches into BigQuery where they're geometries, and then joining those geometries joining those geometries with other geometries that are hosted in BigQuery's public data catalog.
Yes.
So you get a combination of basically where there was flooding, where we saw flat, very low reflectivity, with where the actual roads are in an infrastructure based on OpenStreetMap.
Yes. And by the way, I just saw another request for the notebook. Happy to get it to you. I'm going to attach it as a notebook file to a mail, if that's okay. Let's see, because I can't give you access to this cloud project here because this is an internal cloud project. But if you take this notebook, you can upload it to Colab and it should work. Or you can upload it to cloud. The only thing, actually, let me save you the trouble here. The only change you'll need to make if you want to run it in Colab, and I should just put this in here, is you'll have to do a ee.authenticate. You'll have to add that call, add this in if you want to run in Colab rather than BigQuery Studio. Should be the only change that's needed. I'll send it to, I will send it right now to Nicholas on the thread. Nicholas, and would you be able to forward it to everybody else here?
Yes, yes.
Okay, perfect. And then if you have any trouble, like you can respond and let me know, and I'm happy to answer questions about it. It should work with that line of code, additional line of code. It should work in Colab, and it should work as is without without any other changes in BigQuery Studio. What work are you folks doing that could benefit, that maybe is highly based in vectors that could perhaps benefit from work in BigQuery? Are there any problems that you're all working on? Yeah.
Yes.
Emeka,
Okay.
I hope I pronounced your name correctly.
All right.
Hi, I don't know if you can hear me.
Yes, we can.
Yeah, Thank you for your presentation. Actually, I joined quite late, so I just got towards the ending. I noticed you're using Gmap. Basically, it means you're running the analysis on Python rather than JavaScript, if I'm correct.
Yes.
Yeah, okay. So what I want to ask here, I notice the analysis are majorly in vector. Can we do like a remote sensing kind of analysis where we are working strictly with satellite data within BigQuery? Because majorly currently I'm working on drought analysis, but rather than using BigQuery, I'm working directly on my Jupyter notebook. I'm using Gmap also. So I would love to like integrate what you're doing now. But is it possible to run like a full remote sensing, like analyze different satellite imagery while on BigQuery like this?
Yeah, so it sounds like you're pointing out like it's so Emeka. It sounds like you use mostly the JavaScript code editor, or are you already using GEMAP?
I'm using GEMAP. I use Python on Jupyter Notebook. I don't use I'm not using the JavaScript, but I can also use the JavaScript within Google Earth Engine code editor.
Right. Yeah. This example here uses GEMAP in Python. It does it. And Emeka, do you typically use Colab or Jupyter, or where do you run GEMAP?
Jupyter Notebook. I install Gmap on my local system.
That makes total sense. You should be, so I'll send Nicholas the notebook that I used for this demo, and you should be able to use it locally. Because you're running locally, you will have to run an ee.authenticate command. You'll have to run that command. But otherwise, it should all work. I should also mention, for those of you who use the JavaScript code editor, the code that I wrote here should look very familiar to you, and it would, it happens to be Python, but it would be easy to translate it to JavaScript and run it in the code editor. And then you would just you could visualize the layers and then export, kick off an export task inside of the code editor. And at that point, then you'd want to come in, if you wanted to transition to this part here, you'd end up either in BigQuery Studio or in a Python notebook to run this part as well. You can't query BigQuery from inside the code editor. Emeka, did I answer your question?
Yes, to some extent. But the data you're using now is within BigQuery. So with your script, how can I get access to the data this sample data you're working with from within my system?
Yeah, I should have said all the data in this script is public data. So it should work without any. It should work for you. The work here is to have a sample that will work for everybody.
Okay.
So it's not. There's no private data here.
Okay, yeah. That's great. Thank you.
Yeah, the public data, the Sentinel-1 data comes from Earth Engine's public data catalog, and the OpenStreetMap road segments come from BigQuery's public data catalog. Awesome. Sarah, do you have a question? Yes, you're welcome.
Okay, yes, I have a question. Can you hear me, please?
Yes, we can hear you, yeah.
Okay, so I didn't get why you're working on BigQuery environment. Can you please come again with that? Because I'm trying to see the difference between working on BigQuery's environment and working on the normal Google Earth Engine platform, which is the JavaScript platform that you use JavaScript for. Also, I'm familiar with some of Google Cloud products, but some of them actually require payments. So I don't know if this BigQuery as well has like a limited free version. Then after that, it will be paid for. So these are my questions. Thank you.
Those are great questions. So BigQuery is a paid service. It's not free like Earth Engine. BigQuery does have an amount of free. There's a free tier. Let me see if I can find it. Free usage tier. So, and I'll put this note into the thing here. But so that tells you a little bit about the first 10 gigabytes of storage per month is free, and then the first terabyte of query data processed per month is free. So there is a level of free data that you can do. and if you stay below that every month, you won't pay for BigQuery. Above that amount, you do pay for it. By the way, I just want to say, if you run the samples that I just showed you, I'm confident that they're small enough that they will be well under the free tier, so those won't cost any money. But you're right that above that you would basically typically pay for the compute that you run in BigQuery. And in BigQuery, if you sort of do a query, let's see if I can do this. It'll usually tell you how much it's going to query. There should be like a query button here. Why can am I not finding this? That's not what I want to do. I usually expected to see a little button here that would basically say let's see. Austin 3.1 on lit, not found. Maybe I have to do this, surround it with these block quotes. Let's see that and that. No, I'm not. Some of my syntax isn't right here. I don't understand why. But Austin 3.1. Oh, wait a minute. That's not the. There we go. That's what I need to do. I'm just creating the data set, not the table. There we go. Okay, what I wanted to show here is just this. When you're running queries in BigQuery, in the upper right-hand corner, it will tell you how much data that you're processing. So in this case, it's half a gigabyte. And you have up to a terabyte of queries every month. And as long as you're staying under that terabyte, it's free. I will say, by the way, you can easily get above a terabyte, so be careful, right? Because there is large amounts of data in BigQuery, and if you do if you do a select star, you could easily have this ring up money. So be careful. It's also possible in Google Cloud to set up billing warnings and shutoffs to prevent yourself from accidentally running over and incurring a charge. And Sarah, did I answer your question about BigQuery billing?
Yes, you did. Yes, you did.
Okay, great. Michael. Actually, there's another Michael. Yes.
Different Michael. Yeah, go ahead.
There's another question you didn't answer. Can you hear me?
Yes, Sarah. Yes. What's that?
You didn't answer my first question.
Yes, the first question was just about. I think you were asking about the difference between the JavaScript code editor and BigQuery Studio. Is that right?
Yes.
Yeah, basically, so in BigQuery Studio, you can access BigQuery's data, which is large-scale feature collections. Basically, what an Earth Engine is called a feature collection, in BigQuery is called a data set in a table, and you can use BigQuery Studio to access that data with SQL. In Python, you can access both raster data in Earth Engine, and you can access BigQuery's data. So the reason I did the demo in BigQuery, in Python in particular, was because in that environment, you can access both Earth Engine through our Earth Engine Python API and GEmap, and you can access BigQuery data. Does that help?
Sure, it does. Thank you.
Okay. Yeah, you're welcome. Okay, Michael Wafalu.
So my question was, what is actually the advantage of? I saw you are using SQL. So
Yes.
What's actually the advantage? Like, yeah, there exactly. Because I think also when you work with the JavaScript Google Earth Engine, the default one, I think you can also be able to export either in this format. So what is the advantage of using this SQL? Maybe.
When you're accessing large scale tabular data in BigQuery, you have to use BigQuery SQL. You cannot access it with Earth Engine. So the answer here is that this data is only accessible in BigQuery. It's not accessible in Earth Engine. I think another question is, why do the export at all? Why not just do all of the work inside of Earth Engine? The answer there is twofold.
Yes.
One is that this data, the OpenStreetMap data, is uniquely available in BigQuery. It's not available in Earth Engine. The other answer, I think the better answer, is if you're doing large-scale vector analysis, like in this case, we're only joining for a small section of the Netherlands, Belgium, sorry. But if you, it would work fine in Earth Engine, is the truth. But if you scale out to a global situation like the one I was talking about earlier, where you're joining together 6 million, points against 6 million other points across the entire globe, you're going to find that operation is going to complete a lot faster in BigQuery, those spatial joins for vectors, than they are in Earth Engine. So the performance that you'll get when you're doing that specific type of operation is going to be better in BigQuery than it's going to be in Earth Engine.
Yes, thank you so much.
Okay, yeah, you're welcome. Thanks. It's a great question, by the way, and it really is. It helps us sort of talk about this more clearly. Yes, one more question, and then, by the way, then I actually, in 13 minutes, I have to be at my son's school to watch him do a presentation. So I'm going to jet out, actually. I'll take one more question, and then Michael, maybe you can stay on or drop, or we can follow up afterwards.
Yeah, I can do another maybe 10 minutes. Before, if other people have to leave, I will add just in the chat here the two quick notes. We have an Earth Engine announcement list, which is where our team makes announcements to the community. Please join that if you're interested in learning about Earth Engine feature updates, important maybe breaking changes, or events that we schedule. In particular, we have our big 2024 event is split this year across Dublin and São Paulo, so Ireland and Brazil. If you're interested, applications are now open, so you can reach out there. I provided the links in the chat.
Perfect. Thank you, everybody. I am actually going to drop so I make it on time to my son's presentation, but I will definitely respond back, Nicholas, to the thread with the notebook so that you can all do it, and happy to take questions if you dive in. Awesome. Thank you, everybody.
Thank
Super.
you.
Thanks, Steve. All right, I might get kicked out of this room, but I'm happy to take a couple more questions.
Okay.
Yeah, go ahead.
Yeah, thank you so much, Michael and Steve. So my question is regarding the configuration you are doing now in, let's say I'm using the notebook, and I'm not using the BigQuery Studio Python notebook on the cloud. Now, while I'm now combining or merging the datasets, both of the datasets, I need to configure my notebook to using Google Cloud locally so that I can be able to push or migrate my data to BigQuery still, correct? I have to configure my notebook using Google Cloud.
Yes and no. So it's possible to do all of the processing that Steve showed on a local Python environment. So the cool thing here, the thing that we built in Earth Engine is actually a connector that will push data from Earth Engine in the cloud to BigQuery in the cloud. So you don't have to download all of the data and upload it again. So what you configure is just you basically describe to Earth Engine what the processing is. Earth Engine goes and performs all of the computations, moves those data into BigQuery, and then you go into BigQuery and you describe to BigQuery what the processing should be. And it's all of the computation and all of the data ideally live in the cloud. The configuration that you do is really just getting access to a project. So configuring a cloud project, which is where your processing lives. As Steve mentioned, you don't have to have a billing account. You don't have to have a billing account configured for Earth Engine if you're using it non-commercially, and you don't have to have a billing account for BigQuery, the sandbox mode. So really just the configuration is getting that project set up and then making sure that you have access to Earth Engine and also access to BigQuery. You can do that through a cloud notebook, something like BigQuery Studio or something like Colab, or you can run it locally on your machine if you have Jupyter notebooks or even just regular Python on your machine.
Okay. So it means that I have to connect to BigQuery if I'm using local notebook, right?
Correct. Yeah. You'll want to, if you want your notebook to actually do some BigQuery processing, you'll have to turn on the BigQuery API, and then there's some function calls to drive BigQuery from your local environment.
Nice.
Yeah.
Thank you.
For sure. Any other questions? Sorry, I'm trying to see where I find the hands. I appreciate everybody staying on a little bit longer. I have a couple more slides potentially. If we can do just like 3 minutes of slides, I can talk a little bit more about the technical details. Sorry, we should have booked more time. Happy to chat with you all. Let me just jump real quick. Let's see. Yeah, some technical details. I'm just going to go over this really quickly so you know that it exists. But here, if you see my screen, yep, technical details. There are maximum row sizes. So I mentioned this before. So if you have a feature collection, each row can only be a maximum of 8 megabytes. Right now, it's a little, it can be restrictive if you have really, really big geometries, like the border of Kenya at 1 meter is probably too big to fit in a BigQuery row. There's a maximum number of vertices just based on that size limit. You can choose to have Earth Engine automatically split things up based on the number of vertices, just to make it easier, so that if you have a really big geometry, it will cut it into small pieces. Just be aware that it changes, you'll get more rows in your output because you'll have more geometries. When we're reprojecting, so BigQuery only supports WGS84, EPSG 4326. So these are just like, it's the standard lat long projection. Just be aware that if you have to do any reprojection, you specify an error margin in the Earth Engine export. Also, if you really, really want to move a ton of data, this tool is the easiest way to do it. But if you want to do it really fast, or you move a terabyte from Earth Engine into BigQuery, if you're really pushing the performance boundaries, just know that if you build it yourself using the high volume API to move data around, that's probably going to be the fastest way to do it. Yeah, I'll talk a little bit about future direction. Sorry, I'm going to go a little bit over. I'm excited. I hope you're excited. Today we have this direct export. We're pushing from Earth Engine into BigQuery. You probably wonder, what's next? I think a pretty reasonable thing to expect. We don't have anything to announce yet, nothing to talk about, but I'm optimistic about the idea that you can actually pull data into Earth Engine from BigQuery. So the idea of datasets in BigQuery, being able to read those directly in Earth Engine, is something I'm excited about. Sarah, go ahead.
Okay, Michael, I would like you to please give examples of data sets that is embedded in BigQuery. We know that those in Earth Engine are majorly satellite imageries and the likes. So please, can you discuss more about the data sets embedded in BigQuery? Thank you.
Absolutely, yeah. So BigQuery does really well with big tables. So if you have something like OpenStreetMap, the OpenStreetMap data are millions of lines, points, and polygons representing all different kinds of places and roads and hospital locations, etc. Those data live in BigQuery, and they're too big to work with in Earth Engine today. You can also imagine things like river data in BigQuery. The New York Times published coronavirus rates in BigQuery. There are lots of commercial customers who have things like physical asset locations. So if a company if a company is providing insurance to a bunch of customers, where are those customers keeping track of their locations in BigQuery? River height. If you have a bunch of measurements of river height, BigQuery is a nice place to put them because you can have streaming data over time, showing just continued measurements over time. BigQuery was initially designed as a logs processing tool for Google. So Google has a lot of logs data, and we need to make sense of millions and billions of users' actions and processing every day. And over the years, it's gotten support for geospatial processing, so it can hold points, lines, polygons. It holds kind of general strings, numbers, etc. So it's basically just a place to put to store large amounts of table data and also make sense of those table data. So analyze them, process them. Sound good?
Yes, it does. I'm just trying to differentiate. There's a site where one could download recent data.
Mhm.
It covers rivers and the like. So I'm just trying to connect it if it's the same thing with that in BigQuery. It's also really it's also connected to OpenStreetMap, and it has, I think, Diva GIS. Yes, from Diva GIS. I'm not really sure about the site. I'll confirm. So I was just trying to think that to see if that data is the same as the one embedded in BigQuery.
I'm not familiar with that other system. It is possible to do some of the BigQuery style computation using tools like, tools like Earth Engine today. The real benefit of BigQuery is that it has built-in connectors to a bunch of different tools, and it's really focused on size. So it scales very large to very large data sets.
Thank you very much.
Yeah, for sure. Thanks for the question. And I saw a hand from Sandeep. Yeah, go ahead.
Thank you, Michael, for being continuous support. So my question is regarding Earth Engine. Like I have drone data, but I like to do spatiotemporal analysis with all the data sets that are available in Google Earth Engine. So is it possible some way? Can you direct me to some tutorials or the people who are working in this field?
Yeah, and those are, sorry, you have LiDAR drone data or optical drone data?
Optical drone data, sir.
Okay, yeah. In that case, you probably don't need to use BigQuery. I would, let me see if I can find. I would focus primarily on managing Earth Engine asset data. Lots of users of drone data typically use something called cloud optimized geotiffs. They put those files in Google Cloud storage, so yeah, cloud storage. And then you can pull those into Earth Engine and do processing on top of those. I'm trying to think if we have a specific tutorial for that. Give me 1 second. Check out this documentation. This might help you move some data into Earth Engine. I don't necessarily think you'll need to interact with BigQuery though. Okay, sorry, I only have like 10 seconds left. I'll call it for now, but super nice to meet you all. Happy to do other meetings like this. This is a really nice group of folks, great questions, and yeah, thank you all for your time. Appreciate you going over.
So thank you very much, Michael, for this presentation. It's really nice, and we do appreciate how the BigQuery is connecting to Earth Engine, especially using the GE map. And I think for this few minutes left, I would like to just to welcome Dr. Bushi. You can say a word, because he was here last session. Maybe you can just say a word. It's really important to recognize his presence here. Hi, Bushi, please.
Hello, I have a question. Somebody raised a question. I was asking if we can get a way. If you guys can share somewhere where we can get tutorial for the whole thing, because some of us, well, we have interacted with the Google Earth Engine, but we don't have much information in BigQuery especially. So if we can get somewhere where we can get tutorial, maybe for the beginners, as we move along. Thank you.
I'll leave a link to this blog. This walks through some of the intro to Earth Engine and BigQuery and using them together. It's not using the latest tools or the latest techniques that Steve showed, but it does walk through the basics. Yeah, great to meet you all. Sorry, I got to jump to my next meeting. See you all later. Ciao.
Okay.
Thank you, Michael.
Hello.
Yes. Okay. Yes, bro.
Bye.
Okay, bye. So thank you very much, everyone, for joining us this evening. We do appreciate your presence here, and we have similar kind of sessions running like every month, but some of the sessions come in unforeseen times like this. But we appreciate you very much for coming with us. So you can register, subscribe in our Google group, or check on the website, the community website, so that you can access all the social media channels, and you'll be able to receive the recordings and the slides when they are ready. So at this time, maybe we can say, Michael, please, you can just say something small to the community. Joseph.
Oh, okay. Yeah, so thank you so much, Nicholas, for this opportunity. First of all, I would appreciate all of the members who managed to join us. I know this time, as Nick has mentioned, it's quite challenging to most of us, but since you met and tried at least and join, that's really nice. As a community, we are very glad to have you around, and we will be planning more sessions as we go ahead, and also support, especially from your end. We really appreciate that. Otherwise, from my end, I'm happy, especially for today's sessions. We are trying to bring in. I think it was a kind of a session which was bringing in different technologies as per se, together with the Google Earth Engine. I think it is really nice. I would really also appreciate Nick and Chris and Joseph for the commitment that we have had for making sure that that the community continues running despite challenges here and there. This is really nice. Yeah, thank you so much. I really appreciate it.
Michael is a co-lead in this community, so just don't forget to say that. So
Oh, yeah.
we are happy to answer any question. Please, Rahab, you have question?
Nicholas, just a question. Are you guys also associated with the upcoming state of mapping that is supposed to happen in Nairobi? And maybe what are the criteria for attending that?
For attending?
Yes.
No, maybe Joseph can let us know about that. For myself, I'm not sure about that.
Okay, I can take that question. Thank you, members, for the meeting. During the meeting, I really appreciate your time, and I'm also happy the community is also growing at a greater pace. The moment I share the meeting, maybe links you can be able to share maybe with your friends, and I will appreciate that, so that you can grow as a community and maybe have a greater sessions maybe in future. About the state of the map, which will be happening in September. The criteria, I think it will be rolled out very soon, and I think it will be able, every one of you will be able to afford the ticket. If there will be a ticket, I'm not so sure about it, but once everything is okay, the balance maybe for the registration of the event. Thank you.
I think,
Thank you.
Kevin, you're good.
Sure. Thank you.
All right. So, should there be anything? Oh, Chris, please.
Yeah, thank you so much, everyone, for coming and for the support. Yeah, I just for the updates, you can follow our group maybe, and then our Twitter and our LinkedIn pages. So we'll be giving updates on the next sessions. Thank you so much for attending the event. We really appreciate it. Thank you.
All right. So thank you very much, everyone. So for any communication, if you subscribe there, it helps us to share one big message to most of us instead of sending one email. I think that really helps. So if there is no any other question, we can just close the meeting. Then we see each other in the next session. We'll be communicating through our Google group. So thank you very much, everyone, and you have a good time. We appreciate your presence here. Thank you. Bye.